So today we're going to do compound inequalities. So compound inequalities mean that there are more than just one solution, one set of solutions. So you have a combination, and so our two words that we're going to work with are and or. So there's a difference when you graph them, how they look. So we're going to first look at the number one. We've got n is greater than -2 and n is also less than 6. So when we graph it, we have to satisfy both of those statements. So if I was to graph n is greater than -2, I'm going to put an open circle on -2, and then my arrow is going to go to the right. Now if I was going to graph n is less than 6, I'm going to put an open circle on 6, and then I'm going to draw my arrow to the left. Now, if we notice here, they overlap there. So where they overlap, that is going to be your actual answer. So you've got -2, you have 6, you got an open circle, and then all these numbers in between there will satisfy that n is greater than -2 and it's less than 6. Now, when you have or, you're going to most likely have ones that go different directions. So we have t is less than 0 or t is greater than or equal to 5. So again, it has to satisfy both of those. So t is less than 0, so we're going to put an open circle on 0, and less than, so my numbers are going to go to the left. And t is greater than or equal to 5, we're going to put closed dot on 5, and then greater than goes to the right. So all the numbers to the left of 0 and 5 and to the right will satisfy the equation here, t is less than 0 or t is greater than or equal to 5. Now we're going to actually look at it in what it looks like in an equation. So when there's no word, it's always like an and. So when you have an equation, what you have to do is you have to either split them up and you can solve them separately, or you can solve them the same. So you could split these up and write -3 is less than n minus 5 over 2, and you can solve that. Or you can, and then you would have n minus 5 over 2 is less than or equal to -2. And you can solve both of those separately and then graph them separately. So that is one route. What I like to do is keep everything the same, and you just have two sides of the equation. So when you do something to one side, you got to make sure you do it to both sides. So to solve this equation, n minus 5 over 2, we would want to get rid of 2. So I have to multiply by 2 over 1 to get the 2 out of the denominator. Now, if you do it on one side, you have to do it here on the left-hand side, and you have to do it on the right-hand side, because there's 3 sides to these equations here. So if we simplify the left-hand side, 2 times -3 is -6. And then you keep your symbols, you don't do anything with them. The 2's cross out here in the middle, and you're left with n minus 5. And then you keep your symbol, less than or equal to, -2 times 2 is -4. And then now you have a one-step equation. So n minus 5, again, your goal is to get n by itself. So I'm going to add 5 to get rid of the 5. Well, I have 3 sides of my equation, so I have to add 5 over here and add 5 over here. So -6 plus 5 is -1. Keeping your symbols the same, nothing changes. And then 5 minus 4 is 1. So now I have that n is greater than -1 and it's less than or equal to 1. So on my number line here, I'm going to put, I got to make sure that my 1 and my -1 are there. So since it's an and, I'm going to go in between. So we have to read this direction. M is greater than -1. So I'm going to put an open circle on -1. And then greater than is going to go to the right. And then I'm going to stop because I know my other number is 1. So on 1, I'm going to have a closed circle, and I'm going to go to the left. So that is your answer there. And then from there, we're going to go down to number 2. So then that would be your final answer. So really the only solutions to this equation are -1, not even -1, 0, and 1. would satisfy this equation. So, and you can always go back and check. If I plugged in 0, 0 minus 5, 5's halves would be a fraction, so that would go be between -2 and -3. So now we're going to jump down here to the number 4. So now we have an OR. So there's 2 separate problems here, so you're just going to solve them separately. So we'll do the first one here. So we're going to subtract 2 from both sides. So we have 3x is less than -9. Divided by a positive 3. So since I'm dividing by a positive, I don't have to flip the sign. -9 divided by 3 is -3. So I have x is less than -3. And then here I'm going to solve. So I'm going to subtract 5 on each side. So we're going to do -4t is less than -5 plus 1 is -4. Now you are dividing by a -4. So remember, when we divide by a negative, you have to flip the sign. So if you notice, I went from a less than symbol to a greater than symbol, and then -4 divided by -4 is +1. And then from here we have to graph. So we're going to make sure we get everything on our number line. Start with -3. And then once you have both of them, you can stop putting your numbers there. So now we've got x is less than -3. So I'm going to put open circle, and my less than goes to the left. For t is greater than 1, we're going to put an open circle on 1, and greater than would go to the right. So now everything to the left of -3 would be a solution, and then also anything to the right of 1 would be a solution to these inequalities.